Hi, it's Mr. Blystone. Here is lesson 2 for unit 1 of Algebra 2. What is a function? Let's look at a motivating example here. So it says Bjorn has a summer job from which he earns $5 per hour. His weekly pay in dollars is given by the formula P equals 5H, where H is the number of hours worked. Below is a table of possible values for H and P. So it says that for 1 hour he gets $5, for 2 hours it's $10, and so on and so forth. So it says in the equation P equals 5H, he is called the dependent variable because its value, his pay, depends on the number of hours worked. The variable H is called the independent variable. It doesn't depend on the pay. The pay depends on how long he works. So here's a definition for you to write down in your notebook or in your notes. Function. A correspondence or pairing between two variables such that each value of the first, independent variable, corresponds to exactly one value of the second, or dependent variable. So in that formula we just saw, each value that is substituted for h results in just one value of p. Hence, the relationship is described by this equation is a function. So if we look back, for any amount of time he works, there's only one amount he can get paid. If he works 1 hour, he can only be paid $5. If he works 2 hours, he can only be paid $10. He can't be paid $8 or $6 and $2. No, only one type of value for each number of hours he works. Okay. So we can say that when the variable relationship between two variables is a function, we say that the dependent variable is a function of the independent variable. So in this case, T, the pay, is a function of H. He depends on H. So let's look at an example. It says the table below shows a relation between the year Y and the percent P of public high schools in the United States with desktop computers available for student use. Is P a function of Y? Is Y a function of P? Justify your answers. So let's look at this. A. Is P a function of Y? Well, does P, the percentage, depend on the year you pick? Yes. If I pick 1981, I'll get 42.7%. If I pick 1987, I'll get 99.0%. Most schools had a computer that a student could use. So the answer to A is yes. And the reason, well, we can say that for each Y, there is only one T. Okay. So then, is Y a function of T? Well, let's check and make sure. Because it's possible. Okay, so we have 42.7 gets us 1981, 57.8 gets us 1982, 86.1 gets us 1983, 94.6 gets us 1984, 97.4 gets us 1985, 98.7 gets us 1986, 99.0 gets us 1987, 99.1 gets us 1988, and 1989. Uh-oh. Look there. We have that number gets us one of 2 years. So definitely no. And we could say, and we can give an example. The P, or rather, let's say when. So let's give an example Y. When P equals 99.1, y equals both 1988 and 1989. So y is not a function of p. Okay, here's a you try example. It says the table below shows the average temperature T in degrees Fahrenheit for each month in Honolulu, Hawaii. Is M a function of T? M is the months. Is T a function of M? Justify your answers. Pause the video. Try it out for yourself. See if you can get the answers. And then when you unpause the video, I will see if you were correct. Okay. So A, is M a function of T? So if I pick, so let's see here. 73 for January, 73 for February. Well, already right off the bat, we can see that if I pick the temperature 73, I get two possible months, January and February. And if I pick 74, I get March and December. And if I pick 76, I'm okay. Or 77, I'm okay. 78, I'm okay. 79, I'm okay. But if I pick 80, I get July and October. And August and September both have 81. So M is not a function of T. So, no. We could say some values of T have more than one M. So B, is T a function of M? Well, for each month we only have one average temperature, so yes. For each M, there is only one T. That's simple. Pretty easy. All right, let's look at a few more definitions. Domain and range. So the domain is the set of values which are allowable substitutions for the independent variable. Range is the set of values of the dependent variable that can result from the substitutions for the independent variable. Otherwise, input and output. Input, the substitutions for the independent variable. Output, the resulting values. So the domain is any value it allows you to input, and the range is any value it will output. Now, when we have something written with an equation, the domain may be different. If we have something written with a table, we only know what's in the table. So some situations, we can only limit the domain to what's there. Some situations, we can go beyond sometimes what we see if we know certain things. But some things we can't. Just like the range. Sometimes the range may be other things. Other times, the range is what's limited to where we are. So just note that for these couple examples. So refer to example 1 where p is a function of y. Give the domain and range of the function. Okay. So all we have is this table. We don't have any other values are given to us. And there's no equation stating this. And there's no other values. So what we're going to have to say is that all there is are these values, period. So therefore our domain and we can say it, use set notation. If you don't remember set notation, you take a variable, y is our set, and we put it in these braces, and we separate things by commas. So the domain is 1981, 1982, 1983, 1984, 1985. I'm going to write them all just so 1986, 1987, 1988, 1989, 1990, and 1991. That's the domain, the range. The range is all the values it can spit out. So P equals bracket. So we only put in the unique numbers. So we won't repeat 99.1. So we'll write 42.7, 57.8, 86.1, 94.6, 97.4, 98.7, 99.0, 99.1, we don't repeat it, 98.8, and 99.4, and we close our brackets. And that's the range. Since that's all there is in the table, that's all we can say. Okay, now you try. Refer to the first you try problem where t is a function of m. Give the domain and range of the function. Remember, all we have is what's in the table. So try it yourself, pause the video, then come back and see if you got the answer correct. Okay, domain. We could write these out. I'm just going to say the domain is months of the year. We know it's months of the year, all months. I can put all if you want, all. All months of the year. Let me raise that M so it looks a little better. All months of the year. All right, range. Again, our range is only what we see. So T equals the set 73. Remember, we make no repeats. 74. And generally, we put them in out on numerical order. 76, 77, 78, 79, 80, 81. So that's our range. Pretty easy. All right, so here are some frequently used sets of numbers as domains. Our natural numbers are our counting numbers. Those are basically our whole numbers, but not zero. Some would argue on that, but that's fine. That's what we'll call it, not zero. Whole numbers include zero. Integers include the whole numbers and their opposites, as well as zero. So their opposites, -1, -2, -3. Rational numbers are any numbers that can be represented as a fraction. And remember, we can't divide by zero. Number over zero, that's a no. Real numbers are any numbers at all, basically, that can be represented by decimals. So that includes pi, square root of 2, anything that can be expressed as decimal. Now, you're saying all numbers, aren't they real numbers? We'll learn something else later. But for right now, yeah, all numbers you know are real numbers. And so this makes an interesting thing. All rational numbers are real numbers. All integers are rational numbers. All whole numbers are integers. All natural numbers are whole numbers. So all natural numbers are integers. All natural numbers are rational. All natural are real. All whole numbers are rational. All whole numbers are real. All integers are real. So things like that. Okay. Now let's use a formula here. The area A of a circle of radius r is given by A equals pi r squared. Is A a function of r? Why or why not? Identify the domain and range of the function. All right. Is A a function of r? Well, let's think. If I put in a value of r, how many values of A can I get out? Only one. So yes, for each r, there is only one A. So the domain range, domain. Well, that would be any number greater than 0. So we can say r greater than 0. Can't have a circle of radius 0. We can have anything greater than 0. And it can be all real numbers for the real numbers. The range is, again, the same thing. A is greater than 0 for the real numbers. Pretty simple. Now here's one you try. Says the total cost, C, of V cans of vegetable soup at 59% per can is given by the formula C equals 59V. Is C a function of V? Why or why not? Identify the domain range of the function. So pause the video, see if you can get it. Come back, see if you got it right. Okay, A, is C a function of V? Why or why not? Well, let's see here. If I plug in some number for a number of cans, how many prices do I get? Only one. So, yes, it is certainly a function. Yes, C is a function of V, so yes. Again, for each C, I'm just going to write only one V. Pretty simple, pretty easy. For each C, only one V. Now, all right, so identify the domain range, B. So the domain, well, we can put any amount in there. We can buy any number that's a number that we can buy, a whole number, including 0. We can buy 0 cans. Yes, we can. We can say 59 cents, we don't like it. So we can say the domain is the set of whole numbers. And the range, well, the range is specific. So this is odd. It's a little bit different. It's not a specific, it's not a set we think about. It is the set of multiples of 59. So set of multiples of 59, that's our range. Why? Because that's the only thing we can reasonably get out of it. We can't have 100 cents, $1, because that would be a fraction of a can. 1 and some more. Be less than 2, because that's $1.18, but more than 1. So it would be we can't have a fraction of a can. You just can't do it. So it's the set of multiples of 59 for our range. All right, so let's look at our calculators for a little bit. These are the two very popular ones. We have the TI-84 Plus, and these are the two biggest ones. So these are the ones I'm going to look at. Let's look at some important keys on the calculator. One, of course, is this, the key x squared. It's here on the 84 Plus, 83 Plus, same thing. And then it's here on the TI-30. Yeah. So that's an important key. Now, let's say you wanted to divide 1 divided by something. You could use this, x to the negative 1. That would be 1 divided by something. So that does that. Also, there's a square root. You have to push the second button. Same thing here. This one, and both it's second x squared. To get pi, this one you just have to push pi. This one you have to push second and arc caret. That's also for exponents. So that makes a different exponent. That it's there on this one. Other things you might want to know. Answer. We'll use the last answer in the calculator. Second, negative for both of them. Enter is basically how you say equals. Now, these do it in a normal format, like square root, you're going to hit second. In this case, a squared. To get square root, you'll put in your number and hit enter. This one, you do the same. There are some calculators out there, I don't know any brands specifically, I don't know which ones, that you do it differently. That you hit the number, then you hit the square root key. But TI calculators do it this way, the kind of, I think, normal way. So just be aware that if you have a calculator that's not one of these, it's different, it might do that. So if you hit, for instance, the best way to check is if you hit square root, you just hit square root before you hit anything else, and something weird pops up, it changes. It's probably when you had to hit after. Try hitting 4 and then square root. If you get 2, that's what you have to do. For the TIs, square root comes first. So that's just something to know about the calculators. Just in case you need to know. All right, that ends this lesson. If you're following along and want an assignment to do, go through problems 1 through 26, but don't do 15 through 19 or 22. All right, hope this video helps, and keep on learning.